So yeah, as you know, that I'm director of the Jean Golding Institute. I joined the Department of Engineering Maths very recently from CAME. But what I was going to talk to you most about today is some of my other work around data analytics in payload development for space. And I should apologise in advance, I'm going to whiz through these, but I'm happy to share these slides with anybody who's interested afterwards. So there are good reasons why there's lots of activity in the space sector at the moment. We've seen the establishment for the first time of a National Space Council, which is essentially a subcommittee of Cabinet Office, but also a number of different programs and calls coming through, including a space sector COVID recovery support plan and the instigation of 7 regional space hubs, which are cross-sector, academic and industrial and third sector collaborations. West of England has one. I'm the university rep on that as well. But UKRI has also been looking for ways to better support research in space, both what one would think of as upstream in terms of the development of space systems, design, manufacturing, propulsion, and downstream, the mechanisms of using data from space. So I'm not going to go through all these in detail, but these are some of the kind of key reasons why I think it's a more exciting time to be working in the space sector now than really any point in my last 20 years of research and development. And we can think about the space sector as, and the opportunities as being in these sort of 3 tiers of activity. The first being around low Earth orbit and particularly around PNT systems and science platforms. The second around lunar missions, orbiting systems and surface activities. And then thirdly, Mars and beyond. And I'm just going to give some examples really from those first 2 today, but happy to share information at another time about the others. The statement of the problem in terms of the challenges around data science in space. It's a very, very cluttered environment these days. There's an awful lots of activity going on in low Earth orbit and beyond. And I think there's an increasing awareness that we have to come up with new and strategic kind of clever ways of managing data collection, processing, use. We have problems when our capability of methods really can't cope with the kinds of questions you want to ask and the volume of data that's being generated by the V's. You know, we think about data as being defined by volume, variety, velocity, veracity, and others. And some of the techniques of dealing with this that I'm interested in are around scalable architectural approaches, developments of new software and algorithms, anything which kind of pushes the boundaries of what we currently do and what we could do. Some of you might know that a few years ago we ran a showcase for JGI activities, and one of the keynote speakers there was my kind of longtime colleague Dan Crichton, who's the head of data science for NASA JPL. And together we put together these 2 couple of slides I'm going to show you now, which summarize some of the challenges and where I think some of the most exciting activities happen. So one of the big challenges we have is that we generate a lot of data, too much data, too fast. We can't transport it efficiently enough to store it. And how do we deal with this? Well, we might be able to come up with clever ways of, of data discovery, of better ways of streaming, of triage systems, of developing onboard analytics. The second big challenge that we have is around our data collection capacity. So our capacity at the instrument seems to be continually outstripped by our downlink capacity. And there is some really interesting work going on at the moment around comms in space, satellite to satellite, satellite to Earth, lunar orbiter to satellite, etc., which are trying to address these. But there's a lot of interest in kind of scalable mechanisms for data storage, for advanced methods, efficient methods of data analytics, of taking analytics to distributed systems, for example, which I think are quite exciting. And then the third big difficulty we have is around how we distribute data. We have these massive archives. There are many different, there's a great variety, many different types of measurements and observations. And how do we bring those together into some kind of holistic management system? And the data pipeline as it exists at the moment looks something like this. So we have our slightly dodgy comms connections with our orbiting data generators, if you like. At the same time, we have our data acquisition and command systems that feed into mission operations and instrument operations. which go directly into data processing systems of one kind or another, and then ultimately into management and archiving. But we're not really at the moment focusing enough, I don't think, on big data infrastructure as such, developing new ways of analysing which are efficient and helpful to the large areas of research groups that we're all working with. So what we want to move towards is something maybe that looks a little bit more like this internationally. And this is a slide that was developed in collaboration with European and NASA colleagues for a recent conference. So where we've got kind of the massive data sets at the heart of the issue, where we're developing data, new algorithms, or new kinds of machines to deal with it. And where that feeds, there's a kind of a feedback mechanism from there to our instrument data systems, to our European or NASA archives that feed off those mission operations. So kind of moving the focus to platforms, triage systems, trigger systems, and other kinds of big data algorithms. So I'm involved in a few projects at the moment. I just thought I would whiz through quickly. The first is around risk to health, the second is around the SCEEM project, and the third is around the development for biomission, the EL3 biomission. Space is really dangerous. There are loads and loads of hazards. We know that at our cost from work looking at astronaut capacity in space. And I've been involved in a project recently that's been looking at sensor data that records health from astronauts in space. So we've been egressing data around, for example, radiation dosimetry for individuals, body composition of those individuals before and after flight, body temperature, orthostatic measures, measures of movement. And we've just started to kind of piece that together to understand how different categories of demographic of people in space respond in different ways. And there is a sex-related link to that. And we've also translated that into terrestrial benefit. So for example, from the radiation dosimetry side, we've used that to develop new tools that can actually help clinicians on the ground model radiation doses that need to be given to particular kinds of people, particular ages, particular pathologies, for example, for cancer treatments. And that's freely downloadable. It's called CalDose.
Kate, we better...
Yeah. Is that finish? Yeah, okay, so this is still going on. We've got another project looking at an animal model, a mini aquarium with a spin out of Airbus. I'm involved in a project which is an exposure project for the Bartolomeo system on Sesame, and we're developing the data science infrastructure for the European Large Lunar Lander. And thank you to everyone and all the funders.